Besxar Space Industries is a new space startup that, after 2 years of development, has come out of stealth mode. It's based in Washington, D.C., bringing in advanced space manufacturing to the US Capitol. Their mission is building reusable orbital foundries called fab ships that harness space to create ultra-pure materials and next-generation semiconductors. Manufacturing in space, where there is almost no gravity, sedimentation or settling, results in ultra-pure materials that cannot be made on Earth. These materials can power the next generation of AI, quantum computing, nuclear technologies and defense systems. The idea is not to manufacture the final product in space, but to make the precursor materials or ultra-pure substrates. Think of these as essential building blocks for high-end devices and chips. Despite today's semiconductors having high efficiency, typically 95 to 99%, the enormous scale of compute in data and AI training centers results in huge amounts of thermal heat being generated. Increases in efficiency by using purer silicon wafers will result in reduced generation of waste heat. Today's AI training centers require elaborate water cooling systems to deal with the thermal heat generated, which are not only expensive, but negatively affect water and electricity prices nearby. Another issue with Earth-based fabrication is the impossibility of stopping contaminants, such as oxygen, which end up embedded in the silicon wafers. In the vacuum of space, impurities are much lower, since the manufacturing is containerless. The materials are levitated within the furnace by using electromagnetic forces, keeping the precious silicon away from the crucible walls. Experiments on board the International Space Station have demonstrated improvements in purity of silicon of 10 to 100 times. Besxar plans autonomous orbital manufacturing platforms that return to Earth. In addition to returning precious materials for sale to clients, the return foundry is inspected and refined over time, allowing the company to learn valuable lessons before scaling up the design later on. The founder and CEO of Besxar is Ashley Pilipsin. She previously worked at OpenAI as the first technical director to the Chief Technology Officer or CTO. When they came out of stealth, Besxar announced a launch agreement with SpaceX. A total of 24 of Besxar's fab ships will fly on 12 future Falcon 9 launches. I guess that means 2 fab ships aboard each Falcon 9. The first launch is expected later this year. The surprising part of the announcement was that these fab ships, as the company calls their orbital foundries, will be integrated onto the first stage booster of Falcon 9. This is unusual, as I have never heard of a payload being attached to the first stage of a rocket before. The advantage of this approach is obvious. The first stage returns back to Earth after about 8 to 9 minutes after launch, so can quickly be recovered. In the case of a return to the launch pad, the fab ships can be recovered in minutes, or at worst a few hours after launch. In the case of a landing on a drone ship, recovery may take a few days. It's worth noting that no delicate materials, such as pharmaceutical crystals, can be manufactured because of the high re-entry acceleration, which can reach 3 to 6 G, destroying delicate materials or biological samples. The length of microgravity is long enough to outgas any remaining air in the payload, melt a small amount of silicon and pull it into a crystal, and finally cool and solidify before the entry burn slams the payload with high G-forces. So how much microgravity will be experienced by launching on the booster stage? Well, around 2.5 minutes into flight, after main engine cutoff, the payloads will be in full microgravity. This ends with a boost back burn that starts 6 minutes and 10 seconds into flight, resulting in 3 minutes and 40 seconds of microgravity per flight. This approach means Besxar doesn't need to work on its capsule re-entry system like its rivals such as Varda Space. Instead, it relies on SpaceX's recovery technology, which has proven successful over hundreds of missions already. The founder of Besxar told the Payload website, "We're in a world where there is 24/7 throttling, and today's chips, truly, the GPUs are melting. It really boils down to having next-gen materials that can withstand this 24/7 throttling because, ultimately, data centers have become the new extreme environment." Unquote. The payloads attached to the first stage booster are about the size of a microwave. They're designed to be launch vehicle agnostic, so in the future they could fly on Euclid or the upcoming reusable Neutron vehicle from Rocket Lab. The company has received backing from SpaceX, Anduril, OpenAI, and NASA. Their technology partners include Nvidia, the US Navy, and SpaceX. The ecosystem, competitors, partners, and funding. Besxar falls into the in-space assembly and manufacturing sector, which is becoming more crowded over time. Let's check out their competitors, partners, and funding sources. Varda Space, Spaceforge in the UK, Redwire, Astral Materials, and Sierra Space are all involved in in-space manufacturing of materials or pharmaceuticals. Varda Space have already flown 3 of their recoverable capsules and proven they can manufacture pharmaceutical crystals in space. Spaceforge launched their first payload, Forgestar 1, in June 2025 and successfully powered up their furnace to over 1200 degrees Celsius for over 3 minutes, manufacturing a 2 cm long gallium arsenide ingot with 99.999% purity. Their first payload is a tech demo and cannot return from space. Forgestar 2, which is returnable and 4 times larger, is expected to fly in Q3 2026 on a Falcon 9 vehicle. Spaceforge is the only European space startup to demonstrate a working furnace in space. Redwire is the most prominent company, having made the most progress so far. They have signed an exclusive Earthside licensing deal with Exar Libero Pharma to sell an osteoporosis drug that was manufactured on board the ISS. They have a permanent orbital furnace on board the International Space Station and have agreements to fly payloads with commercial space station companies such as Starlab and Vast Space, and with Sierra Space's Dream Chaser vehicle. Astral Materials are also involved in in-space manufacturing. Of all these companies, only Redwire has commercial deals. All other startups are in pre-revenue phase or working on tech demos. Varda Space claims they will sign a commercial deal in 2026. Upcoming events. Besxar should be launching their first orbital foundries on Falcon 9 rockets later this year. We don't have any details on launch dates yet though. The in-space manufacturing and assembly market continues to grow with a number of startups working on propellant depots, space tugs, in-space assembly, and the manufacturing sector growing, with Besxar joining the ranks. Fun times in space. Do you think in-space manufacturing of ultra-pure silicon and other materials will turn into a viable commercial market soon? Leave your thoughts and opinions in the comment section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Space News Live is on Saturday evening or Sunday morning, depending where you watch from. The live stream is a great way for you to share your thoughts and opinions on the videos I posted this week or on any space topic in general. I highlight the most thought-provoking comments on videos I've received, along with late-breaking space news and previews of upcoming content. If you got the time, please tune in and say hi. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.